Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Fikri Aris Mespawi. My matrix number is AE10041. Right now I will show you the simulation for the activity 1 in experiment 8. The title is the series resistive inductive circuits. We need to build the circuit in any software electrical that we can use. I'm using Proteus Professional, and let's go to the simulation. As you can see, I have built the circuit. This is the V source, this is AC emitter, this is this is AC voltmeter, this is the inductor, and this is the resistor, this is the ground. We set the value of V source is 10 volts and 50 hertz. We will set the first value for resistor and inductor is 210 ohm, and the inductor is 0.4 Henry. Okay, we just run simulation. You can see the value for the first variable. The value of current is 28.9 milliampere, and the value for the volt is 7.07 volts. Okay, then we'll change to the other sample. We just change this value, this inductor 0.8. Run the simulation, and only the value for the current a bit different change, and the value is 21.5 milliampere, and the volt is same just like before. Okay, then we will pick any other changes value. I will pick this one. Just stop. This is 0.4. This is 860 ohm. And you can see the value for the volts is same, 7.07 volts, and the value for the current is 8.14 milliampere. I think that's all for the activity 1 in experiment 8. Thank you. Okay, for the activity 2, we need to build the circuit just like the instruction asks us. Just use any other software for the electrical. I'm using Proteus Professional, and let's go to the simulation. As you can see, this is the circuit that I have built from the instruction, and this is the V source, this is the emitter, this is the voltmeter, this is the resistor, and the other one's load. This is inductor. And the first value that we need to put in the circuit for the resistor is 210 ohm, for the inductor is 0.4 Henry, and for the V source is 10 volts, 50 hertz. Okay, then let's just run the simulation. As you can see, after the simulation is run, you can see the value for the volt for this circuit in this value. The value of volt is 7.07 volts. The value for current is 65.5 milliampere. Then we can try the next value. Stop this, change it to 0.8, and run the simulation. As you can see, the value is decreasing, and the value for this sample is the volt is 7.07, is the same from before, and the value of current is 44.0 milliampere. I think we can just go to the next value. I will just random pick. I'm pick see this value. Okay, we change the value for resistor is 40070 ohm, and the value for this is 0.4. Okay, run the simulation. Here you can see the value for this load. For the value that we change is for the current is 57.8 milliampere, and for the volts is 7.07 volts. I think that's all for the activity 2 in experiment 8. Thank you.
Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Abdullah Kiman bin Abdullah. My metric number AE1900055, and now I would like to run simulation for activity 3, which is RC series circuit. So this is the complete circuit diagram for activity 3. In this circuit we have one AC supply with 10 volt and 50 hertz, one AC emitter, one AC voltmeter, one resistor, and one capacitor, and one ground. So for the first sample, the value of R is 390 ohm, and for the capacitor is 2 microfarad. So we run the simulation. So as we can see, for the voltmeter we have the value 7.071 volt, and for the emitter we got 4.33 milliamp. So next sample, the capacitor is 4 microfarad. So as we can see, the voltage meter is remain as same, which is 7.071 volt, and for the AC emitter we got 4 milliamp. Okay, for the next sample, the value of capacitor is 8 microfarad. So the voltmeter is remain as same, and for the emitter we got 12.712 microamp. So for next sample, for value of the resistance is 210, and for the capacitor is 4 microfarad. Run the simulation. So for the voltmeter, as we can see, remain as same, and for the emitter is 8.617 microamp. So the next sample, for the value R is 470. So as we can see, the voltmeter remain as same, which is 7.071 volt, and for the emitter is 7.669 microamp. So for the last sample, which is the value of R is 860. So we run the simulation. So as we can see here, the voltmeter is remain as same, and the emitter reading is 6.044 microamp. So that's all for the simulation for activity 3. Thank you. Okay, next for the activity 4, which is RC parallel circuit. So this is the complete circuit diagram for activity 4. So for the first sample, we using the value of resistor, which is 360, and for the value of capacitor is 2 microfarad. So we run the simulation. So the value for the emitter is 18.671 microamp, and for the voltmeter is 7.071. For the next sample, the value for capacitance is 4. We run the simulation. So as we can see, the value for the voltmeter is remain as same, and for the emitter is 20.204 microamp. So next sample, the value for capacitor is 8 microamp. Then we run the simulation. So the voltmeter is remain as same, and for the emitter is 25.428 milliamp. Okay, next sample, the value of R is 210, and for the value of capacitor is 4 microamp. So the voltmeter reading is remain as same, and for the emitter is 34.832 milliamp. So for the next sample, the value for R is 470 ohm. Then we run the simulation. So for the voltmeter remain as same, and for the emitter reading is 17.480 milliamp. So for the last sample, the value for resistor is 860 ohm, and then we run the simulation. So as we can see, the reading for voltmeter is remain as same, which is 7.071 volt, and for the emitter is 12.127 milliamp. So that's all the presentation simulation for activity 4. Thank you.
My name is Amar Sofri Bezamzuri Arifin, matrix number AE190061, and I'll be presenting activity 5 for experiment 8. So, first step, we set the value for Vsauce, which is the amplitude is 50, but the frequency is 50 Hertz. And after that, we set the value for resistor, inductor, and capacitor according to the manual given, which is for the first sample, for the resistor is 390 ohm, inductor 0.4 Henry, while capacitor is 2 microfarad. And after we set all the parameters, we run the circuit, and we will get the value, which is the voltmeter is recording with 35.3 volt, while the emitter record is 23.6 milliampere. And after that, we change the parameter for resistor for the second sample, which is 470 ohm, while the inductor and capacitor value remain the same. And we run the circuit again, and we will get the value for the ammeter, which is 23.2 milliampere, while the reading for voltmeter is remain the same. That's all for activity 5. For activity 6, first we arrange the circuit as the lab given. First one, we set the base source with voltage peak 50 volt, while the frequency is 50 hertz. And we set the parameters value for each load, which is VR, which is resistor, inductor, and capacitor with 390 ohm, 0.4 Henry, and 2 microfarad respectively. And then we run the circuit. After we run the circuit, we will get the value for each of the circuit, which is this value for voltmeter and this value for ammeter. And after that, we stop the circuit and we change the parameter for resistor into 470 ohm, while for inductor and capacitor remain the same. And we run the circuit again, and we will get the value for voltmeter remain the same, while for the ammeter we can see there is a little difference, which is now the value is 268.89 milliampere. That's all for activity 6 for experiment 8.